So we talked yesterday about adding and subtracting being kind of the more involved of the operations with fractions because we have to have a common denominator. And I didn't say this, but I'll say it now. The easiest way to get a common denominator, when I say easiest, it's the easiest to think of, but not necessarily the most efficient, is just to take one fraction's denominator times the other side and just go both ways. So take the 17 times the left fraction, the 4 times the right fraction. That's the easiest one to think of because it always works. It may not be the best option, but it does always work. So here, multiplying both top and bottom by the same thing, we'll get, you know what, before I do that, let's kind of clean it so you can see it better. Right, so 17 times 5, what is it? Thanks. And 17 fourths is 68. And then 200 over 68. Everybody good on where those came from? Okay. So with a common denominator now, we can just add straight across on the numerators. And it's good. Now you could look to simplify that. Try to divide both top and bottom by 2, 3, 4, or whatever. For time's sake, let's just leave it the way it is. Okay, same thing here. I see that it's probably best to just multiply this 5 times the left fraction and the 2 times the right fraction. And then we'll get 25 tenths and 24 tenths. When we add those together, we get 49 tenths. So far, so good? Okay. Same thing, but this time subtracting. And these are a little bit of a pain with these bigger numbers, aren't they? So, I don't know. Let's just have you tell me 19 times 17, just to save some time.
323.
That? Okay. What's 19 times 8? I could probably do that. Oh, there was this. Thanks. Minus 33 times 8.
264.
And 152. So 23 and 36 is 59, I think. Does that sound right? Cool. Okay, so subtracting and adding, pretty much the same process in terms of setting up your fractions. Let's go do this subtraction real quick, just to finish that concept off. All right, what is 4 times 47? So 160, 188. Right? Okay, so then we subtract, then we get 43, 60. All right, how about multiplication? How do we do that?
You want to
Just straight across, yep, just no worry. These have a common denominator, but it actually doesn't matter. Even if they didn't, we could just multiply straight across. And in this case, with multiplication, we do have to multiply the denominators too, not just the numerator. So this will be 9 fourths instead of 9 halves. Okay, last one. How about division?
change flip.
Good. So we're going to keep the first one, change to multiplication, and then flip the second one. So keep, change, flip, copy, dot, flip, sometimes people say. 14 times 8 is 112, and then 39. Okay. So let's put this back into context. Like, why are we taking time to do elementary school math? Besides the
Yeah.
fact that it is very useful in the real world.
Get an idea,
Huh?
get an idea of it.
Well, I mean, you should have an idea of how to do this already. Why did we talk yesterday? What are we going to use fractions for in this unit that we're about to do? Kind of have started.
For, what it was called. Like the unit we're doing, like we're using fractions
To do probability.
yeah, probably.
Yep. Okay, that's why. So it is useful in life, guys. You do come across fractions. You probably have, right? At your house? Have you had to deal with fractions before there? Yeah. But specifically for us, we're doing it just so that we're competent with doing this for probability calculations. Because a lot of our calculations will be with fractions. It's not going to really get much worse than this, for the most part. So you'll, if you're handling this fine, you'll probably be okay. Okay, how many are there on there? How many problems?
12.
Alright, so you're like 5-ish?
4.
How many did you get done?
7.
Okay, how about you guys, Bailey?
6.
You were having a bad day, sir. So I'm going to give you 5 minutes, get however many more you can get done. Again, the focus of this unit absolutely is not fractions. I just wanted you to have a chance to review working with them before we get started. So here are your answers. We'll just scroll through them. Where's the rest of them? How'd it go? I mean, these ones with still variables in them, like 7, 8, 9, we won't have that in our probability. So if the other ones are going well, I think you're fine. Any questions on any of these? Would you like to do any? No? Alright. 4, okay. Alright, so this is division, so we need to do the keep, change, flip. We'll keep this first fraction, change to multiplication, and then flip the second fraction over. Now, when I'm looking at this, I see that I'm going to have to multiply 5 times 26, which I know will make a big number. And I know that 5 and 15 can be simplified because one is on top and one is on bottom. So if I divide both of these by 5, I'll get 1 and 3. And now that makes 1 times 26, which is a lot smaller number. So now we can just go straight across. We'll get 26, and then 13 times 3 is 39. So that also saved us from having to do 13 times 15, which is harder than what this is. Does that help? Okay, so if you simplify beforehand, often, if you can do that, then often your numbers are going to be easier to deal with. Any others?
7.
Okay. Yeah, I'm glad someone asked about one of these. So with this a here, we're not going to be able to combine to a single number because we have to be able to combine like terms. So I see a 10 and a 5. Well, we know we can make 5 be a 10, right? So we don't have to change both of these. We could just multiply this side by 2. Well, 2 over 2, right? Because 5 times 2 is 10, and now we have a common denominator. So rewriting this, we'll get 9a over 10 plus 2 times 2 is 4, and 5 times 2 is 10. So now we have a common denominator. And now we can just add. But remember two things. One, you don't add denominators. So when you're adding, you just leave the denominator alone. And then two, I cannot combine 9a and 4. Like they can't be 13a or anything like that. So it just has to stay separate like that. Is it okay at this point to reduce 4 and 10? So look up here, like if you're writing, just pause for a second. Is this okay to divide this by 2 and divide this by 5, or by 2 to get 5? Is that okay? Like reduce, in other words, or simplify. And then it would say 9a plus 2 over 5. Do you think that's okay? It's not, okay? It's definitely not okay. How come?
Because you didn't change the value of the 9a.
Good. Yeah, this one is also over 10, not over 5. So I can't use this side to reduce the denominator without doing something with that other side. And it's really comes down to the plus sign. That's what's fouling this up. Okay? So don't, when you have a plus or a minus in a numerator or denominator, don't pick and choose. Don't cherry pick pieces of it. Okay? Here's another example. What if this was 4x plus 3 over 10? Actually, let's not do 10, since we just did over 8. Can I do 4 divided by 8 is 2, and leave the 3? No, same thing. If you flip it over, same thing. So, only simplify. Don't simplify just parts. I guess let's say it that way. Okay, any others you'd like to do? Yeah, Karen? 8, okay. Is anybody going to ask about 9? Okay, I'll just grab it too. Okay, so this one, we have now a variable in the denominator, and we're subtracting, so we have to have a common denominator, don't we, to subtract. Well, when I look at this, I see that 3 could be made into a 6 by doing that. Yeah, so if I multiply this 3 by a 2, now I have 6y on the bottom. Can I just multiply the denominator though? No. So we'll do the numerator also. And then that becomes 2 times 2 is 4 over 2 times 3y is 6y. And then over here, this fraction is the same as it was, because we didn't change it at all. Okay? And then we just subtract. 4 minus 5 is negative 1, and 6y stays the same. Does that help? Okay, and then down here, this one's, the denominators are totally different, right? Like there's no just modification. So, I need this denominator, this first fraction, to have an x in it, and this second fraction has to have a 7 in it. Do you see that? This is that case where it's best to just multiply. Let me get rid of the 9 actually. Best to just multiply by x over x here, because now I have an x in the denominator, and by 7 over 7 on this side. And do you see both of these have x times 7? So there's our common denominator. So in the numerators, we'll get 1 times x, which is just x, minus 21. So x times or minus 21. And then, of course, our denominator is 7x. That's tempting, again, to divide that 21 by 7. Or maybe divide the x and cancel it off. Is it okay to do? Nope, not because of that minus sign. We can't do that. We can't separate it. It would be going against order of operations. Okay, so with the exception of those, are you doing okay on the numbers ones only? Okay, awesome. Well, here's what we're going to do. I'm going to introduce some basic concepts in probability, and then we'll try out a little probability exercise. So why don't you grab your yellow notes, and your front page is already full, and it doesn't even look like probability. So maybe put a little note down here. Something like that. So you know that you're going to have it coming up. Oh, if you still have room, then never mind, you're fine. I guess I just write big. Have you guys studied probability before at all? Okay. Most students don't. It's something that always gets pushed to the end, and then you never get there. Let's kind of call this section basics. Of course, we'll get past that fairly quickly, but let's just call this basics. And we'll do some exercises with basic probability as well. Does anybody know Dahlia? Is she a friend of you? Just hoping she's okay. Okay, so first let's define it. I'm about to write a word that sometimes students get mixed up on, so I'll write it and then tell you what I mean. I'm putting it in quotes because it represents a lot of different ideas. So the chance of an event occurring. I have had students in the past think event means like a concert or a ball game or something. Like it doesn't mean that. What do you suppose the word in quotes event could reference?
Something like a change or
An outcome.
An outcome. Okay. And you said what?
a change in something.
Okay.
Something weird happens.
Yeah, and it doesn't
For
even
the
have to be.
problem.
Like, you've all flipped a coin, right? We could define an event as flipping a heads on a coin. That is an event, right? It doesn't mean anything significant. It just means what we're talking about. Or the probability that a bird will land in that tree, just because I'm looking out the window, right? Like, something like that. It doesn't have to be a big deal. So, it really focuses in on this word, chance. And I think you guys are probably familiar with that, right? I liked Ammo's word for event as an outcome of interest. And sometimes that word outcome is kind of more relatable. How do we show probability? You've all come across it in your life. Like if you've ever watched the weather, you've seen probability before. How do they tell you probability? They use percent.— What else? What other ways do we typically do that? fraction. And then kind of the intermediate between those is a decimal, right? Okay. For us, fractions and percentages will be the most common, but you will have the option to do decimals as well. I probably should have had you review this, but how do we take a fraction to a percent?
Don't you divide the two numbers together?
Which one? Well, which one gets divided?
The bottom one, the top one.
Top gets divided. Okay, that will give you a decimal. And then how do you go from decimal to percent?
Multiply by the bottom number.
Oh, that would take you back to the start. All right, let's write it. Come on, board. So for a percent, you divide top by bottom, then times 100. Or times 100 moves the decimal place 2 to the right. Okay? I need to figure out a way to, like, times 100 does this. It's not both. Don't do both things. Okay? So right now there are 7 of you, and if you need your calculator, that's fine. Because being able to do percentages is some of the most important math that you ever learned up to this point, honestly. Because you use those all the time. Like your taxes are a percent, sales tax is like your income tax, is a percent. Sales tax is a percent. Discounts is a percent. You know, if you get a coupon or something. What else? Weather. There's tons of things that are percents. So let's say 5 out of you 7. 5 of you 7. Like Snickers bars. What percentage of you like Snickers? If 5 of the 7 of you like them. And you couldn't use your calculator. Like, it's not going to tell you the percent, but you can do this with it. So I'm asking for a percent. I'll write it up here as an example of it. So 5 out of the 7 of you like Snickers. So what percent of you like that? And I guess I could ask. Raise your hand. I'm guessing it's probably everybody. Does anybody not like Snickers? No. Well, look at that. I was right. It was 5 out of 7. Okay. So we divide top by bottom and get a decimal, which is what decimal? Should be around 80 by 0.8.
0.714.
I said 0.714. Did you guys agree with them? Okay, and now what do we do with that to make it a percent? 2 to the right, so 71.4%. Okay? So now if we take that concept to probability, here's how that would sound. Let's say somebody walks in here at random. What is the chance that they pick somebody who likes Snickers? They just randomly, let's say they put your names in a hat and randomly draw one out. What's the probability that the person they pick, likes Snickers? Isn't it the same thing? They have a 5 out of 7 chance of picking someone who likes Snickers, which is 71.4% chance of picking that person, right? Does that make sense?
Yeah.
So again, these two are definitely the most common. Like 5 out of 7 students is very relatable, but so is 71%. Would you say that person has a good chance or not a very good chance of picking someone who likes Snickers? It's pretty good, right? It's almost 3/4, so yeah, it's good. So speaking of that, let's kind of give ourselves a reminder of scale. So probability value. Scroll this a little bit. So thinking, we just did one with 71%. What is the range of probability values? Okay, 100 is the max. Is what you said? What's the minimum? It's 0, okay? Alright, let's pause there for a break and then we'll come back. The value of probabilities ranges from 0 to 100, but you guys have all heard 110% before. Does that apply to probability? Well, before you answer that, let's define what these mean. If something has a 0% probability, what does that mean in terms of the outcome? Yeah. It will not happen, right? Not happen. Like expecting snow in July in Grand Junction. It's pretty much a 0% probability. How about 100% probability?
It's guaranteed to happen.
Yes.
It will happen.
It will happen. So if 100% is it will happen, can we have 110%? No. It can't happen more than it's already going to happen, right? So with probability, the max is 100% or a fraction value of 1, right? Doesn't go higher. 110%, that's okay in other applications, but not probability. Okay, what about in the middle? We know is 50%. If we're on this side, the upper side of 50%, what would you say about the outcome? How would you describe it?
It might happen. It is more likely to happen than not.
Okay.
Awkward.
It could happen, but also not happen.
Yeah, well actually, if you're above 50%, it is likely, mathematically likely to happen, right? You have more than a 50% chance. So then down here, it's unlikely, technically. Now we all know that the weathermen say 40% chance of rain and then it rains. But that doesn't mean, 40% doesn't mean it won't, it just means it's not likely to, right? Technically. So all of your calculations in here will be between 0 and 1, or 0% and 100%. You will not get one that's higher than that, because it doesn't make sense. And of course, certainly negative probabilities make no sense, right? Okay. All right, hopefully all of this has been kind of familiar. This will be new. How do we notate or show probability when we're doing calculations? And you'll be glad because you won't have to write the word probability 50,000 times. So we're going to write P, capital P, not lowercase, but capital P. And then parentheses around whatever you're looking for. Okay? So put the outcome of interest in here. Okay, of course then we'll say equals whatever the equals is. So P of whatever outcome. We'll do an example. So let's say we're flipping a coin. And we want to know the probability of tails. Okay, so you would just write tails. Now some events or outcomes are long, right? Like you have to actually describe it. Probability of getting rain on Thursday or something. You know, like sometimes it's kind of longer. Try to abbreviate so you don't have to write it fully. And usually you can do that pretty well. Like this, like probability of like Snickers. So it's a little longer, but at least I didn't write a student likes Snickers in the class or something. Make sense? Speaking of flipping coins, what is the probability of flipping tails? It is, yeah. Since we know that one. And actually we know this one too. It was 75% in this class. Okay, underneath the word notation, I want you to write this. Always give your answer with this notation. P tails equals or something. Okay? I shook up. Yeah, those things are frustrating and scary. Okay, two more things. Then we'll try this out for a little while, and then we'll come back to some paperwork. You guys know that, don't write this, but you know the symbol, the tilde? We used it for similarity, remember? Well, in probability, we're going to use that to say the word not, okay? So, put in here probability of A. And let's write this in quotes just so that we're familiar. Of A occurring. That's what that says. If we want to talk about A not occurring, put a tilde in front of it. And now we say probability of not A. So think about something like this. Like if A is the probability of rain, probability of not A would be no rain, right? Which could encapsulate a lot of other weather conditions, but that's what that is talking about. In terms of the relationship, put this, we'll talk more about it later, but it's if 1 represents 100% probability of something happening, then 1 minus the probability of A is the probability of not A. So you could think of it back to weather. Tomorrow, 100% chance some weather will happen, right? Let's say it's got a 10% chance of rain. What's the probability of not rain? If tomorrow it has a 10% chance of rain, what's the probability of not rain? 90. It would be 1 minus 10%, right? Or 100 minus 10%. Good. All right. Last thing is huge. I showed it to you yesterday briefly, but this is going to be the backbone of everything we do in this unit. So I'm going to actually put a box. Let's box it. Are you sick of writing probability yet? basic probability formula. Okay, here it is. So whatever we're interested in, I'm going to leave blank because we know that's going to change based on what we are studying. Are you guys good? Does that mean number to you? Okay. So number of outcomes of interest out of the total outcomes. Actually, I want to add a word between here. I want you to say, and I'm sorry if you already wrote it, but I want you to add the word total possible outcomes. The important word is total. Sorry about that. So let's think through a couple of easy examples. Flipping a coin. How many possible outcomes are there? There are 2. If I say outcome of interest is heads, how many ways can that be? 1. So do you see there's our 1 out of 2, or the 50% that Bailey said earlier? Okay, now you roll a die. How many possible outcomes are there when you roll a die? A normal one is 6, right? 1, 2, 3, 4, 5, 6. If I say what's the probability, or how many ways can we roll a number less than 3, how many of those are there? Less than 3. It's 2. So 2 out of 6. See how we're starting to structure our probabilities and why we use fractions? Okay, so before we go do some probability stuff, I want you to put an arrow to the bottom and say start with this. I'm going to put my arrow closer to the total. Okay, as we get into this further and it gets more complicated, it's easier to start with finding the total and then figure out how many ways you can have it happen. Okay? All right, pausing there. So when you played the game first, pretty much everybody spread them out with only a couple stacks. The second time, most everybody kind of clustered it a little bit more. So you're going to use this page as a reference. So we're kind of creating a cheat sheet, so to speak. Okay. This is dice combinations for rolling 2 dice, like you just did. Okay. Now, let me ask you this kind of philosophical question. Is it the same thing if you roll 2 dice at once, like everybody was doing, as rolling 1 die and then another? Or rolling 1 die twice, let's say it that way. In other words, you all held 2 dice in your hand and rolled. Is that the same as if you only held 1 die and rolled it 2 times? Is there any difference between those 2? Okay. So we could say or 1 twice. Whichever way you want to think of this. Okay, so I think we'll have enough time to do this depending how good your skills are. You probably should have 2 colors if you can. Like pen and pencil, or 2 different colors of pen or something. So what I want in the box for each one is the sum and the product. What is a product? That's multiplying, okay? So here's how I'm going to set mine up. I'm going to use this color is the sum, and this color is the same color. So let's do green. This color is the product. So I'll kind of show you how I'm going to make mine look. So 1 plus 1 is 2. 1 plus 2 is 3, etc. 4, 5, 6, 7. And you're going to just write in these sums. And then on the other side of the box, 1 times 1 is 1. 1 times 2 is 2, etc. all the way down. Make sense? Okay, we want this to be a reference so you can look at it quickly. So I'll finish filling out. Is everybody clear on what you're doing? Okay. And then as you do this, you'll start to notice some patterns. So take note of them. And at the end, I don't know if we'll get to it today, but at the end we'll kind of highlight those patterns. Try to use the patterns to make you fast.